Welcome to day 18 of our data science journey. Today, we're exploring Seaborn, a library that simplifies the creation of beautiful and informative statistical plots. Seaborn is renowned for its ability to create various types of statistical plots, each serving a unique purpose. It's built on top of Matplotlib, offering a high-level interface that makes generating complex visualizations straightforward. These plots help in visualizing data effectively, making it easier to identify patterns and relationships within datasets. Heatmaps excellent for visualizing correlation matrices. A heat map uses color to represent the values in a matrix, which makes it easy to see how different variables in your dataset relate to each other. For instance, a heat map can show the correlation between different features in a dataset, highlighting stronger relationships with more intense colors. This can be invaluable for quickly identifying patterns and relationships within your data. For our lesson today, the dataset we're using is the famous iris dataset, which contains measurements of different flower species. Now we want to understand the relationships between different numeric features in the selected dataset. First, we load the iris dataset using Seaborn's load dataset function. This dataset includes measurements of iris flowers but contains both numeric and non-numeric data. We focus on the numeric columns by selecting only those with data types float 64 and int64. This is crucial because correlation calculations only make sense for numeric data. Then we compute the correlation matrix with numeric data core. This matrix shows how strongly each numeric feature is related to every other numeric feature, with values ranging between -1 and 1, from perfect negative correlation to perfect positive correlation. Finally, we create a heat map of the correlation matrix using Seaborn's heatmap function. The heatmap helps us visually identify these relationships. By setting a not true, we display the exact correlation values in each cell, and Camp Cool Warm provides a color gradient where cooler colors represent negative correlations and warmer colors represent positive correlations. Boxplots provide a summary of one or more numeric variables, showing the median, quartiles, and potential outliers. Boxplots are particularly useful for understanding the distribution of the data and identifying any anomalies or outliers. For instance, if you're analyzing the distribution of a variable across different categories, a boxplot can clearly show how values spread and where outliers are located. The boxplot function from Seaborn is a powerful tool for visualizing data distributions. In the iris dataset, there are 3 species, and we want to find how the sepal length vary with these 3 iris species. What exactly do we see in the plot? We have 3 separate boxes, one for each iris species. Each box represents the range of sepal lengths for that species. The boxes show where the middle of the sepal lengths fall. The bigger the box, the more variation there is in sepal length. Inside each box, there's a line that tells us the median sepal length for that species. The whiskers extend from the edges of the boxes to show the range of values, but only up to a certain limit. Values beyond this limit are considered outliers. Any dots outside the whiskers are outliers. These are unusually small or large sepal lengths that stand out from the rest. This plot helps us quickly see how sepal length differs between species. Pair plots are useful for visualizing relationships between multiple variables in a dataset. A pair plot displays scatter plots for each pair of variables, allowing you to see correlations and interactions between them. Additionally, it shows the distribution of each variable on the diagonal. This can be particularly insightful when you want to explore how different features interact with each other and identify any potential patterns or clusters. Pair plot is a function from Seaborn that creates a grid of plots. It generates scatter plots for every possible combination of numeric columns in the dataset, and along the diagonal, it places a distribution plot, like a histogram, for each feature. The hue argument adds color coding to the plot. Here we are coloring the points based on the species column in the dataset. This means that for each species of iris flower, setosa, versicolor, and virginica, the data points in the scatter plots will have different colors, making it easier to compare how the species differ based on the measured features. Pair plot are a really useful tool when we want to visualize relationships between all pairs of numeric features in a dataset. Yesterday, we covered Matplotlib basics, which provided you with the fundamental tools for creating plots. Today, Seaborn enhances these capabilities by offering more advanced statistical plotting techniques with ease and style. Next time, on day 19, we'll dive into Plotly, a library that allows you to create interactive, web-based visualizations, adding a new layer of engagement and interactivity to your data presentations. See you soon!